This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. This week is episode 601, and we've got Michael Geyer joining us from Bakersfield, California. We're going to talk about using heat to remediate buildings, and this is going to be a great discussion. Before we get started, let's thank our sponsors. They are the reason IAQ Radio Plus is still free, and we want to announce our two newest sponsors. First is the Institute for Inspection, Cleaning, and Restoration Certification, the IICRC. Learn more at iicrc.org. And the second is Healthy Buildings America 2021, to be held in Honolulu, Hawaii, August 10th through 12th, 2021. Learn more at hb2021-america.org.
IAQ Radio Association sponsors are the American Conference of Governmental Industrial Hygienists. Learn more at acgih.org. The Cleaning Industry Research Institute. Learn more at ciriscience.org. The Indoor Air Quality Association. Learn more at iaqa.org. AIHA, Healthier Workplaces, a Healthier World. Learn more at aiha.org. And the Restoration Industry Association. Learn more at restorationindustry.org. IAQ Radio industry sponsors are AEML Laboratories. Learn more at aemlinc.com. Particles Plus. Learn more at particlesplus.com. And Healthy Indoors Magazine. Subscriptions available at healthyindoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio Trivia question.
Hello, everyone. Congratulations go out to Dr. Neil J. Zimmerman, Professor Emeritus of Industrial Hygiene at Purdue University, for being the first person to answer the most hotly competitive IAQ Radio trivia question ever. He identified the most penetrating particle size as the term used to refer to the particle size at which an air filter has its lowest arrestance. The IAQ Radio Trivia question for today, Friday, October 2nd, 2020, has been sponsored by Ideas, the solution chemistry company providing unique solutions to odor removal, surface cleaning, and decontamination problems. Here is today's IAQ Radio Trivia question. Name the 1953 novel presenting a future American society where books are outlawed and firemen burn any that are found. Back to you, Joe.
Thank you, Cliff. Hey, before we introduce Michael, I also want to mention next week is the RIA virtual conference called Fragmented No More, October 6th and 7th. Learn more at restorationindustry.org. So today's guest is Michael Geyer of KERNTEC Industries in Bakersfield, California. He has over 30 years of hands-on experience in construction, engineering, environmental, and biological sciences, developing work, estimating project costs, negotiating contracts, managing staff, and executing assignments. Mr. Geyer has worked on thousands of tasks over the course of hundreds of projects, some exceeding $80 million in value. And today we're going to focus on using heat to remediate buildings. Welcome to IAQ Radio Plus, Michael.
Hello, everybody. Glad to be here.
Great to have you on. Let's start with get the background. What's the definition of thermal remediation? So what is this thermal remediation?
I'd like to make an analogy to pasteurization. You're trying to bring up a structure, a space, a material, up to a temperature at which you're either off-gassing volatile chemicals, you're killing off a biological, like pasteurizing milk. You could take dirty milk, run through a pasteurizer, make it wholesome, and it's safe to drink. Pasteurization does not remove the biological organisms, it just kills it off. And that's where heat treatment can, if deployed properly, differentiate from pasteurizing, in that if you put those HEPA filtered fan units in the space or the structure you're treating with heat, you can effectively remove some of those particulates that are released or mitigated during the heat treatment process.
Let's talk a little bit about the different strategies used for heat remediation. It's not just, throw in some heat and walk away. I guess there's different levels of heat. Maybe we could start with that and talk a little bit about using heat as a remediation tool.
Sure. So, when people come after me and say, hey, is heat treatment going to work here? One of the questions I ask is, what are you trying to affect control of? I work with those folks that have multiple chemical sensitivities. They're saying, I've got an odor, I've got a chemical, it's making me sick, it's in my new house or my new space or my new office. And I use heat treatment in that situation as a bake out. We're trying to get a delta T between where they typically run the temperature, 75 degrees, and maybe 110 or 120, where we're trying to change the the temperature to get the vapor pressure of some of those high boiling or low boiling chemicals to off gas. Formaldehyde is a classic example. There's a lot of engineered wood materials in furniture or other TI work, and we're not trying to dry out a building or kill a biological. We're trying to off-gas some high boiling chemicals in that difference in that temperature, such that when we go back to that 75 degrees creature comfort zone, they don't have the odors, they're not being affected. That's what I refer to as a bake out. Different strategy than we're doing a dry out or affect mold remediation on a water damaged building. In that situation, we need to go to a more elevated temperature. Based on a lot of my research, there's very few of the organisms in our environment that like or can survive a temperature of about 145 degrees. So we want to get up to that temperature pretty quick, hold it there, allow the heat to absorb into the building materials or the space or whatever's there we're trying to treat. We're doing a dry out. We're trying to affect control of those biologicals. We hold it there until we've got the heat that penetrates whatever material it is. If it's a wood frame structure, we need to get the hollow cavity wall system. If it's a multifamily building and we're only heating one apartment per se, we got to be careful of the others. So there's a little bit of an art and a science there, but we're trying to dry it out. We're trying to kill the biological, the mold, the bacteria, the protozoa there, get into the interstitial spaces, and affect control there. And then, so I mentioned the bake out for chemicals, the dry out water damaged buildings could kill off the molds that are there. But then the third strategy that I've been involved with a number of times is to affect a biological kill. I've been involved in a number of projects where somebody's been afflicted with a group A pathogen. More often than not, it's like a staph or, the flesh-eating bacteria. Or it might have been a fatality in there of somebody that died of a group A pathogen. And, my concern is the crew that's going in to do the cleanup thereafter to try to keep them from becoming ill or injured from that pathogen. If I've got a pathogen like that and I need to kill it off to protect the guys that are going in or the crew that's going in to clean it up, I might be less inclined to save the drapes or the nylon furniture or the rubber gaskets around a window. And I'm going to take it up. I've done it. And most of the time I'm involved with this, it's a residential structure. or a residential unit that somebody has succumbed to a group A pathogen, I've run it up to 195 degrees for 24 hours. And other than some very heat tolerant spores, I don't know of a human pathogen that's going to survive 195 for 12 to 24 hours. And that's the soak temperature. That's after we've already heated up those things of thermal mass, and then the stopwatch clicks as soon as we hit that target temperature, and you go 12 to 24 hours holding it there, you're going to kill off a pathogen pretty readily. And then the people going in to do the cleanup, the soft demolition and the like can do that with, in your typical EPA level C ensemble instead of level B. I've gone into a number of these single family dwelling where it's been, a lot of residue from the person that was sick or injured. And I mean, it's pretty rank. Putrescine, cadaverine, that's the odors that you smell there. And after that kind of heat treatment, 195 degrees, it actually smells like a piece of toast. It's sort of refreshing. And based on some of the colony counts that we get from our wipe samples, we can't sterilize a place, but when you're going down to 1 or 2 colony forming units per square centimeter with a lot of those samples coming back ND, we can get really close at 195. So bake out, chemical off-gassing, dry out is the, we're trying to remediate the mold and dry out the building materials. And then you've got the biological kill. So there's sort of 3 temperature zones that I look at as you're trying to heat a structure or a space or a material up. What's your strategy? And then deploy the heat that fits the strategy.
Well, I'd like to go into more detail on the strategy in a moment, but before we do, I'd like to first have you explain to folks, what was your first project on this type of thing? When did you personally first use heat for remediation?
For remediation?
Yes.
When I knew what the hell I was doing, or when I didn't know what I was doing. One of my claims to fame is I paid my way through college replacing rotten bathroom, kitchen areas, and off-campus student housing when I was in San Luis Obispo going to Cal Poly. I had already had, 10 years of construction experience when I realized that I was good with my numbers. I saw my share of fatalities in construction. I mean, I saw 5 fatalities in construction. I've picked up body parts. I've stopped arterial bleeding. I almost got killed twice in construction. I didn't want to be a statistic in the Bureau of Labor and Stats. So I was good with my numbers. And so I ended up going to Cal Poly and showed up at campus with $50 in my pocket and had to basically work my way through school, had a construction background. And I started developing a clientele in this off-campus student housing because I could do the soft and the hard demo and restore this off-campus student housing. I got into some molds. I got into some rotten stuff. I was remediating without respiratory protection, without HEPA filtered fan units. I was heating, and it's easier to heat up and dry out rotten, wet drywall than trying to remediate rotten, wet, slimy drywall. So we basically bring in halogen lamps, kerosene heaters, propane fired heaters, put a box fan in the window, dry things out, do our soft demo. I mean, I got pneumonia twice, really, really, really bad because I was sucking a whole lot of spores. And I was telling Cliff, one of my funny things was we were busting out all the rotten drywall in a bathroom. I had the box fan in the window, and the fire department shows up. There was enough black spores going out through that window that somebody thought this place was on fire. And that was just mold spores going out the window. So that, when you say heat, that's the first time I was using heat was back in the late 70s, early 80s. on my construction projects, trying to pay my way through school. So once I got out of school and I started working for an environmental engineering company in Long Beach, and I got a little bit more educated in personal protective equipment and negative pressure enclosures and the like. And I was involved with a fair amount of lead, asbestos, and heavy metal remediation. You know, in the early 90s, one of the contractors trying to get work for my clients was Dave Hedman of Precision Environmental, trying to do the asbestos abatement and the mold abatement. And then about 1998, Dave Hedman approached me and said, hey, what about heating things up and doing it in environmental remediation? And I said, great. He says, I'm trying to develop a patent. I sort of laughed at first, but Dave was a brilliant guy. He was a visionary. He saw from the asbestos and lead abatement technology a way to deploy heat much more safe so people aren't getting exposed to a lot of mold spores, a way to contain it, control it, and remediate buildings with heat. So by 1998, 1999, I think I was doing a better job of it, and I helped Dave Hedman and Thermopure develop their process at that time. And I think there's a lot of merit for the science of that. I mean, it's common sense to heat things up. I think you can heat anything up. You know, 50% of the time, you can just do it with common sense. But the other 20, 30% of the time, you need to have the science behind it, the thermodynamics, the material science, the mechanical engineering, the safety. And then there's a good 10 to 20%. It's the art of applying the technology. You know, I've seen a lot of failures with those that have been applying heat. You know, they think they're good at a detached single family dwelling, and then they get in a multifamily building, big apartment building. They're trying to deal with one apartment and they booger the neighbors next to them. So there's definitely an art to deploying the technology safely and effectively.
Let's get into that art a little more in a little more detail. You mentioned bake out, and there's a term, I guess, that you've used, gentle bake out. How do we do a gentle bake out? Let's start with reminding people what types of contaminants you're trying to remediate during that gentle bake out, and then talk a little bit about exactly how you do it.
Okay. So a good example of a gentle bake out, let me go back to this guy, Alan. I won't say his last name, but just call him Alan. He had a house built in the Del Mar, San Clemente area, California. Alan suffered from a lot of, let's call it multiple chemical sensitivity syndrome. And it's pretty well codified, MCSS. He hired contractors and environmental people, wanted all low emitting materials in his house. You know, it had plaster walls, it had no carpet, it had ceramic flooring. But when that house was built, there was something in there that Alan could not live with. I mean, the guy just would go in, his skin would flush red, he couldn't breathe, there was a chemical off-gassing in there. I speculate it was the coating that they put on the cherry wood cabinets in there, but I'm not sure. Had a lot of people trying to remediate it, and all of a sudden it came to me, and I thought, well, brand new house, sounds like it needs a chemical bake out. So we deployed heat. We brought it up to about 120 degrees. 125 was my max on this one. The problem with brand new cabinetry, if you take it too hot too fast, you'll pop the glue joints. So we had to do very gentle increase of heat. Now the issue about the 110 to 120 degree range is you're at the range that's the incubation for biologicals, a lot of molds and bacteria. But this was a new house. It was not water damaged. His issue was trying to get rid of the chemicals. So we deployed propane heaters in that situation because it was the most available heat source and appropriate for the project. A lot of air exchange. We manifolded all the exhaust air to one 24-inch flex duct coming out. So we were blowing heat in multiple smaller propane heaters spread around the structure, a lot of fans inside to distribute the heat. So we had equal distribution uniformity. We want to keep the temperature at the floor level similar to the ceiling level. And he had a lot of 16 and 18 foot high rooms. Stratification's a big issue. So we created a real turbulent air environment. And we maintained this temperature of about 100, 125 degrees day after day after day. And I mean, I used photoionization detectors and other sorts of field equipment. And I thought I had it after 3-4 days. I thought I had it in pretty good shape. Alan Bell shows up, and Alan couldn't get within 10, 20 feet of that exhaust pipe, and his skin would go red. I mean, within minutes. It's like, oh no, it's still there. So we kept heating 24 hours a day, day after day. I think we went into day 7 or 8, and Alan shows up, and he could actually walk close to the exhaust of that duct, but he said, hey, it's still there. I will never forget day 12, or 11 or 12, I think it was, or 13, somewhere in that range. It was over a week. Alan shows up, he walks to the exhaust duct, he picks the duct up and sticks it over his head. And we're all sitting there with our eyeballs really big. And we're going, uh-oh. And he sits there. And I mean, a minute or 2 or 3 goes by. And all of a sudden he throws it off the side. He goes, I can breathe. So we knew we had off-gassed whatever it was there to a point that Alan could go in his house. So we cooled it down, removed all the equipment, opened up the doors and windows, just let it equalize for about a day, closed it back up, let it sit there for 24 hours. And then the real test was, could Alan walk through his front door and not flush red and all of a sudden his throat closed up? He was a happy guy. And so, you know, that's probably the best example of a bake out. I mean, I've got another one where, you know, a contractor applied a wood preservative to a house. The family said it smelled like diesel, and we did the similar sort of situation. And after about 7 or 8 days, we got most of those straight chain aliphatics and other hydrocarbons to off gas, gentle heating, so we didn't booger up. Some of the materials there worked really well. However, we were doing our cool down. We sort of walked in there and had a nasty smell in one of the bedrooms. Really bad. After a little bit of looking around, it was the baby's bedroom, and there was a half-filled pail of diapers in there that were really rotten and composting, and it's now on our checklist. Some of those things you need to remove before you deploy heat. 120, 130 degrees causes things like diapers to compost.
You know, you mentioned stratification and the deployment of fans to try and break up that stratification. Do you use the fans in a certain direction? Do you try and push the heat back down, or do you just try and create turbulence? How many fans would you need in a typical 3-bedroom, you know, home, 1 per room, several per room? Can you give us a little more detail on that?
Good question, because this is one of the failures I see with people deploying heat, is a contractor that tries to do it on the cheap or tries to make a little too much profit on the job, and he doesn't put enough fans in there. These are all heat tolerant fans, especially when you're doing a dry out. When you start going up above 120, 125 degrees, you have to have equipment that is heat tolerant. With respect to how many fans per room, typical detached single family dwelling house, let's use that as an example, you could probably get away with 1 decent 1000 CFU fan unit per bedroom. You're going to put a couple of them in a living room. As the room size increases, you got to put multiple fans. If you've got high ceilings, like Alan's house, he had these 16, 18-foot ceilings. Most of the fans we put on the floor point them at the ceiling, so they're just blowing air up, and it creates a real turbulent environment. You need turbulent air environment to minimize the stratification, to get the distribution uniformity on the heat. And when you start talking really tall ceilings, you may have to start putting pedestal fans in there as well as fans on the floor. I prefer a lot of floor mounted fans because you got to get that cooler air off the floor and push it in the ceiling, which will cause the hotter air to flow back down. But with really tall ceilings, you're going to need pedestal fans to get up a little bit higher up. You mentioned like a 3-bedroom home. You may have 11 individual rooms in there. You may have 20, 25, 30 fans. You need an aggressive air environment. Again, one of the more obvious failures I see where heat treatment is not effective is the lack of fans, the lack of aggressive air movement. You've got to push air around.
Cliff,
But that also, go ahead.
I just had a follow-up, back to, Alan's job, or the one you were talking about with the, smelled like diesel, the, wood preservative treatment. Have you ever tried desorption prior to heat? Either using a solvent, such as ethanol or isopropanol, and water solution, applying it to surfaces, to get it to evaporate off quickly and draw, emitting materials out with it? Or have you ever used, heat in conjunction with, adsorbents such as, activated carbon or molecular sieve or something like that?
Carbon or zeolites.
Right.
I have not, because I find that's an expense I don't typically need, is to bring in a carbon or a zeolite. Now, Cliff, how do you regenerate carbon or zeolites? You heat them up to drive whatever the, carbon's good. Activated carbon is really good for your hydrocarbons. Your zeolites are better at adsorbing your alcohols and water-based chemicals. But to regenerate them, you regenerate them with heat. You start having a adsorbent coupled with heat, its ability to adsorb those chemicals is substantially reduced. I have never coupled those two technologies. I have at times, activated carbon is one of those things we do with ventilation systems when we're trying to adsorb hydrocarbons so the emissions are try to meet some sort of a permit or control an odor. But I've never add the two together because I believe you'd get less effective control, but I don't have any experience adding them both. When I use activated carbon or a zeolite, it's without elevating the temperature.
Thanks.
Usually just ambient air.
We're getting close to our halftime here, but before we get to that, Michael, when you do the gentle bake out, is this effective for things like formaldehyde? Is that part of your gentle bake out approach?
Formaldehyde is one of those hydrocarbons that appears to work well with heat. Again, it's a gentle bake out. There's a lot of engineered building materials that have formaldehyde, aldehyde-based resins in them, your particle boards, your plywoods, your OSB material. Yes, and so the gentle bake out, formaldehyde is one of those things that its off-gassing decreases with time at an ambient temperature. How to accelerate that curve so that off-gassing drops off quicker? You elevate the temperature, it matures faster, off-gasses faster. If you're doing a bake out with the aggressive air and excessive exhaust and removal of the air so it doesn't reabsorb into your calcium sulfate of the gypboard that's in a building or a plaster material. You can get it to age quicker, off gas quicker, and get it out of the dwelling unit faster using a gentle bake out. I've been pretty successful with that, yes.
Okay.
Am I going to get it all out? No, but my intent is to get 80-90% of it, which might off gas in 6 to 18 months, to try to get that to accelerate down to a period, a couple days to a week.
I got you. Okay, we're going to go to halftime. When we come back with the second half of Michael Geyer, we're going to talk a little more about the next level of heat remediation, the dry out. Before we go to halftime, I want to mention our two new sponsors, the IICRC, the Institute for Inspection, Cleaning, and Restoration Certification. You can learn more at iicrc.org. And Healthy Buildings America 2021 in Honolulu, Hawaii, August 10th through 12th, 2021. You can learn more about that at hb2021-america.org.
IAQ radio industry sponsors are Particles Plus engineers and manufacturers of feature-rich particle counters and air quality monitoring instrumentation. Learn more at particlesplus.com. Count on us. Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at healthyindoors.com. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at aemlinc.com. Association sponsors are the Indoor Air Quality Association, a multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Learn more at iaqa.org. The American Industrial Hygiene Association, AIHA, Healthier Workplaces, a Healthier World. Learn more at aiha.org. And RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org. CIRI, the Cleaning Industry Research Institute. See more deeply through science and research. Learn more at ciriscience.org. That's CIRI science.org. ACGIH, advancing the careers of professionals working in the environmental health, industrial hygiene, and safety communities. Interested in defining their science at acgih.org.
Okay, we're back with the second half of our interview. We've got Michael Geyer out of Bakersfield, California. We're talking heat remediation. Michael, let's go to the next level, the dry out. You've got a water-damaged building. There may be biological organisms starting to grow in that water-damaged building. Can we use heat? Is it common sense that heat is going to help with drying that building out?
Short answer to your question is yes. Heat is going to help you dry it out. And yes, you're going to have things growing in the building. I have yet to see a sterile building that when it gets wet, all buildings have got some sort of biological reservoir in there, and things will grow when it gets wet. Now, you still have to do your gross removal. I don't think, I have been asked to deploy heat where somebody says, I don't want to tear out my drywall, can you just heat it up and dry it out? Yeah, how much money you got to spend? I think that saturated sheetrock and the insulation that's in those exterior walls held between the sheetrock and whatever exterior siding you have is just going to take a long time to dry out that sponge in there. And it's going to be real difficult to get effective dry out when you've got saturated materials, let's say at floor level, and the ceiling and the roof is not. You're going to be heating up for weeks and weeks and weeks. So you've got to complement and have your gross removal. But what heat really comes into play, the remediation contractors, they remove the drywall, they pull out the wet dry insulation, and they get out their scrub brushes and they start scrubbing. You still can't get whatever biological is growing between the sole plate and the stud. There's a space there you can't get to, or the blocking, or the diagonal bracing, or let's say it's up high in between. There are places you can't physically remove the material. If you want to try to remove some of it, whatever, that's fine. But the beauty to heat after you've removed the saturated materials and extracted whatever water you can is it's going to get into those spaces that you can't demo, you can't get to physically. It's going to dry it out. It's going to kill the biological. It's going to, as I tell my customers, it resets the biological clock. I mean, heat is great for historical structures where you can't remove the architectural finishes, where you've got to preserve that material to some degree. Heat can take those water damaged buildings and remediate them and minimize the demolition or the soft demo. So it's very effective at drying it out. And you don't have to, there's all sorts of heat methods. You could use electrical, you can use indirect, you can use direct fired, but heat, raising the temperature, raises the vapor pressure, water's gonna come out of those wet materials. You gotta get that controlled exhaust air out to get that water out of the building or the space you're trying to heat. It's very effective, yes.
Now, when I'm all with the extraction, getting out as much of that liquid water as you can, removal of the, very wet insulation and drywall and so forth. Do you start the heating after that process is completed? Can you do them both at the same time? I would imagine it's going to make it tough for people to do the remediation.
Good question, Joe. If you're working in a cold environment, it's a little nicer to do the demolition when you're, 85, 90 degrees inside. So yeah, you can, I have deployed the heat in combination with the gross removal when the outdoor temperature is 30, 40 degrees. And if it's below freezing, it's really nice to get those materials out before the inside freezes up. So there's times that you can do them both the same, but nobody likes working at 95, 100, 110 degrees. So you can deploy it both at the same time. You want me to share one of my bonehead moments of when it's not a good time to apply heat?
That's where you learn from.
I made my mistakes. So, just say you're in the northern latitudes and there's a big multifamily building being built. It's about 60 feet wide, 200 feet long, big subfloor crawl space. In the framing stages, they've got the floor down, the first set of walls. It gets hosed in a rainstorm. And then it snows. Okay, so the outdoor temperature is like 20 degrees. Well, they sweep all the snow off the floor, but a lot of that water got in the crawl space under the subfloor, and all your engineered wood, the joists, and they were using 1.1 OSB tongue and groove for the subflooring. Everything's wet in the crawl space. So it's like, oh, well, let's dry it out. I mean, the mold was just starting to grow. So it's like, let's dry it out. And, propane heaters was the most available heat source at this job at this time. So we started blowing a bunch of hot air from direct fired propane heaters in one end of this building. It's like a long rectangle, 60 feet wide, about 210, 220 feet long. So we're blowing air at one end, letting it exhaust out the other end. Did I say it's 20 degrees outside?
I don't know if you did, but now I know.
Yeah. When you burn a fuel gas, that hydrocarbon, I don't care whether it's propane or LNG, turns into CO2 and H2O vapor. Well, that hot air was moving through that crawl space, and at some point it hit the dew point, and one end of that building, when we realized we weren't getting really good exhaust at the other end of the building, and we went in there and looked, yeah, we packed one side of the building with snow. So the water vapor crystallized out, turned into snow, and then we had to go down and shovel snow out of the far end of the building because we were pumping propane fired air in this side of the building. That was a really good example of when we probably should have used electric heat or something other than a fuel gas.
I see. I
It
see.
happens.
So what was the solution on that? Did you go to electric heat or?
Yeah, we ended up bringing in a bunch of diesel-fired generators, a big bunch of inductive heaters. Well, this was after we crawled in there and were shoveling snow out the other end. I mean, we had to get that bulk water out of the area and we were trying to dry out, all the engineered, the joists and the underside of the plywood from the underside, and electric heat.
Now, what other remediation tools and techniques are you using at the same time as you're heating? Are you using HEPA filtered air filtration devices at the same time? What type of air movement are you using? Just axial fans, or are you using something maybe from water damage restoration world, some centrifugal fans, or how are you doing that?
So axial fans by far will move more CFU than your axial or squirrel cage fans. Squirrel cage fans work better if you have a pressure issue where you've got a restriction, but you can't beat axial fans for just pushing large volumes of air. You need to create an aggressive air environment. If you're in an enclosed space, now like that crawl space, we were just blowing air from one side and letting it push out the other and through the vents in the stem walls. But if I've got a water damage, let's say single family dwelling or a multifamily dwelling, you have to engineer the hot air in and engineer the exhaust air out. You have a lot of fans inside, creating an aggressive air environment to minimize the stratification and increase the distribution uniformity of the heat. Hot, dry air is a piss poor way to transfer BTUs, but it's what we have to do here, and when you create that kind of aggressive air environment, which you need to do to affect control, you're going to generate particulates, and you have to put heat tolerant HEPA filtered fan units in there with a heat tolerant filter media, especially if you're going into those elevated temperatures. Some of those filter elements, they're polypropylene or they're a fiber that gets sort of gummy and doesn't work well at elevated temperatures. There are safety devices you need. Especially if you're using direct fired heaters, you have to have CO monitors. When you're deploying heat in the beginning, you have to have your technicians go in and out of the space, and sometimes there needs to be a little bit of an adjustment. We use a lot of remote temperature sensing equipment to monitor what's being heated, how fast, where we're trying to affect our control. And sometimes you have to push the fans around or the ductwork to heat up the cooler spots or to move it away from those spots or those areas that are getting a little hotter. There's some significant safety issues with people going in to a heated space. Especially when you start going over 120 degrees, the higher the temperature, the shorter the time. I've walked into these spaces that are running 150, 160 degrees, and you got to be in and out of there in 3 to 5 minutes. I don't care how much oxygen and how little the CO concentration is inside, the temperature is going to get you.
What is that the temperature range on the dry out you're looking for? I mean, we talked about the bake out that wasn't real hot, like 110, 120, I think maybe. Are you looking at going to 150 for the dry out in that range?
So based on my research and the research of a lot of others, the mesophilic bacteria, fungi, and the other things we're trying to control, not many of those live past 145 to 147 degrees. So I shoot as a target temperature 155 plus or minus a delta 5. If I can do that in the space or the volume that I'm trying to control, I hold that temperature for 60 to 120 minutes, depending on what it is, I've affected a good biological control at 155 degrees plus or minus 5. I do not want to go under 150. And I try to keep it below 160 to 165 because there are heat intolerant building materials that you need to be paying attention to. Yes.
Can you mention a few of those heat intolerant building materials? I would assume a lot of your contents you want out of there, but I could be wrong.
Well, so yeah, there are heat intolerant contents you have to be careful of. You don't have to remove your refrigerator, the contents thereof. We can cover them with a thermal blanket. And actually, I've done situations where we've had a glycol unit, that puts refrigerated glycol and insulated pipes and goes in with a small heat exchanger and put it underneath those thermal blankets if we had to keep something cold that couldn't be removed. But yeah, there's a checklist. Photographs are going to get boogered. Anything that's nylon. You have nylon drapes, we're going to make them crispy at 160, 65 degrees. But your natural materials, your wood, cotton, usually not a problem. Synthetics, yes. You might want to take that, the clothing that's hanging in your closet with those plastic bags from the dry cleaner. Yeah, we're going to shrink wrap those on your nice tuxedo.
Okay.
So there are, there's a list of materials. Thermopure's done a really good job of developing that, and we've all done it more by mistakes.
Yeah.
Anything else?
So we learn a lot of things. What about building materials themselves? What are the most sensitive to heat building materials?
Okay, so let's assume we've got a mature structure, because if it's a brand new building with brand new paint, flooring, you're going to craze the paint and you're going to booger the flooring if it's brand new. That's a bake out when you're gentle heat. If you got a water damaged building, you're interested in getting the water out and arresting and killing off the biologicals. So, there's a balance there. If you have too much heat blasting out a window, you're going to booger those rubber seals and they may shrink and then they may leak at a time. We typically keep sinks on for water going down your ABS pipe. Not that ABS pipe is heat intolerant to 160, but some of the rubber seals are donuts and the drains are. I'm trying to think, drawing a blank on some of those others, but most of your wood, your sheetrock, your electrical systems, there are some gaskets that you'll find, or some of those things in your lights or electrical systems you have to pay attention to. But most building materials, most construction materials found in your common home, multifamily, commercial building can tolerate 155 degrees plus or minus 5 very well.
I've got a couple text questions from listeners here. One is, I'm sure fresh air intake is optimal. However, does it benefit to use an activated carbon charcoal filter to assist in absorbing the off-gassing being promoted by the heat? We talked a little bit about this before the show, but I think a lot of people would have missed that. Would you go ahead and discuss that just a minute?
Activated carbon is great at absorbing hydrocarbons out of the air. We're talking about C3 and above on the hydrocarbons. Doesn't do good on your alcohols and some of those other water-based chemicals that you'll find off-gassing out of. And alcohol is a common solvent in your latex-based paints. The thing about activated carbon, you start blowing hot air through that, thinking if I'm doing a bake out and I've got chemicals I'm trying to get out of a building, I'm just blowing it out of the building. I'm not trying to capture those chemicals and not discharge them to the atmosphere. The thing about carbon is you start blowing hot air through it, its ability to adsorb hydrocarbons decreases with increasing temperature. So you're trying to exhaust hot air through activated carbon. It becomes much less effective at that absorption chemical principle, and those chemicals will be passing right through it.
I've got another text question. Mold testing is irrelevant for remediation assessment and clearance, according to Ed anyway. However, a focused sampling strategy can be used to validate a remediation strategy? Is there any data supporting bakeout to restore surfaces and air to undamaged microbial conditions?
Now, the bakeout is the one where we're doing a much more gentle temperature, 110, 120 degrees. I'm not going to that level of temperature if I'm trying to affect mold remediation. I'm only going to those low temperatures in a non-water damaged building to affect off-gassing as some of those high boiler chemicals that won't off-gas at creature temperatures, 75, 80 degrees. On those we're doing a dry out and trying to dry out water damaged buildings and affect mitigating molds and fungi. If you do your confirmatory sampling, 155 degrees for 60 to 120 minutes, you will find most of those spores become inactive. I won't say it, you're sterilizing a building, but you're doing significant log reduction of the active mold potential colony forming units there. You can get orders of magnitude reduction of active mold spores.
Viability of the spore. Now, what about removing those spores, though? What other supplemental techniques do you use to get them out of the building altogether? I guess the air movement itself and the filtered, if you're using HEPA filtered air filtration equipment, those are obviously helpful.
Yes, like you said, how many fans do you need in a room? And I said maybe one per bedroom, multiple ones per living room or whatever to try to stir the air up. You're putting almost an equal amount of those HEPA filtered fan units in there that are scrubbing the air at the beginning of the heat treatment when the heat's going up, during the time it's heating, and during the cool down. Those HEPA filtered fan units need to be scrubbing the air the whole time, because you're going to create an aerosol. You're going to create a serious aerosol with that kind of air movement, turbulent environment, hot environment. It's not to be taken lightly. It's a serious aerosol, but it's easy to control.
Yeah. Okay. And Cliff, I want to make sure if you wanted to jump in here, you get a chance.
I did have one question. Okay, I have one contractor who says that fans and dehumidifiers are the best way to dry a building. I have other contractors that say that heat's the best way to dry a wet building. Which do you think is correct?
I've done both. I find heat to be faster than a dehumidifier. Dehumidifiers work on a refrigeration cycle. I don't know of anybody using dehumidifiers and really creating aggressive air environment. You create aggressive air environment, you're going to get particulates. You add heat to it, and you get an order of magnitude more particulates, because you're drying out the particulates as well, and they become more airborne, more buoyant. Dehumidifying without heat has its application in situations where you have a lot of heat intolerant materials. If you've got the time and you've got the coin and you've got a situation where heat will cause more damage than what is allowed or beneficial, yes, dehumidifiers and fans would be probably the way to go. It takes a lot longer. How long can you be out of your building? That said, if you have a heat intolerant materials, don't apply heat. Use the dehumidification process. This is where the science and the art come into play. You've got to pick your battles and figure out what you're trying to control, what your strategy is, how to do that, and what are the resources of the customer.
I got another text comment here, and I want you to listen and see what you think on this. We have experience with the use of heating to supplement other drying methods for really wet materials that need to be dried yesterday. When only propane heaters are available, visible condensation can be prevented in some cases by keeping them at least several feet from the affected surface. This can accelerate drying, but they prefer a tented dehumidifier. Tented dehumidifiers may work better for them. Any thoughts on that?
I'm having a hard time understanding what the root of that question is.
I don't know so much a question as a comment that to prevent condensation, you got to keep it at least several feet away from the affected surface.
Okay, so yeah, let me jump in there. If you're getting condensation from propane-fired system, the condensation's happening on a cold surface. So if it's really cold outdoors and you're heating with propane indoors, single pane glass windows, yeah, you're going to get some condensation. I could see that happening in the situation where it's cold outdoors. And I've done my share of bad propane use in really cold climates. So if it's going to be cold where it's less than 40 degrees, I may be more inclined to use an electric heat source than a propane or LNG fired burners. That is a very valid issue, the condensation, if it hits a cold surface.
I've got another text question I think is really a great one for this point in the show. How do we measure at the end of the dehumidification process we are good and we can stop? What instrument, what percent humidity is acceptable? And I got the same question on the drying, using heat for drying. How do we know when we're done? Are you looking at moisture content of building materials? How exactly do we know?
What's your strategy here? Are you trying to kill off a biological, or are you trying to dry out a building? Dry out a building, we can go through, there's those easy, 2-pin moisture sensors out there. You're getting it under 10%. Of course, if you live I live in a fairly dry, arid environment. I get down to 10% in my cellulose-based materials, I'm golden, because it's, the humidity here is low. We're not going to get that in the southeast where the humidity's there. You're trying to get back to a homeostasis of what a baseline was before. Depends on what part of the country you are, what your environment is. 10% moisture inside your wood materials may be a little excessive in Florida. So it really depends. We do mold sampling confirmatory. We do the dual pin. A lot of my dry outs, I'm also looking at my temperature profile, 155 degrees, 60 to 120 minutes. I'm in pretty good shape for the biologicals. Now I'm just trying to get down to that 10 or 15% moisture.
Mike, can you stick around another 5-10 minutes? We're 12:59. I don't want to run over too much, but I do have another question or two.
I can stick around.
Great. I want to talk about some of the safety concerns, but also I want to go a step further on that previous question. Can you, when you add heat, you lower the relative humidity. Can you get it too low? Do you have a lower end that you're looking to maintain?
Good question. I'm typically not, I do a lot of indoor air quality work, and I've got equipment that can measure relative humidity in real time. I don't recall us actually monitoring, data logging, paying attention to the relative humidity that often. We're looking for moisture content of building materials. If you've got a water damaged building and it's a stick frame structure, wood frame structure, and you have 2x4, 2x6, 4x4s in there, I'll put thermistors, bury it 2 inches into a 4x4 to see if I'm getting my heat into that dimensional timber if I'm trying to get my heat to penetrate that deep. But I don't recall us really measuring relative humidity. So I've got to punt on that question because I don't recall us doing a lot of data logging for RH.
Okay. Or even dew point. You could use dew point as opposed to RH, but I just thought I'd bring that out. The other thing that I'd like to do, if you would, real quick, is Talk about some of the safety concerns when using heat. I think it's always important to end with that. Are we going to have? Are you going to elevate carbon monoxide in some cases? What are some of the safety concerns?
A very good question. So, what's your heat source? Is it a fuel gas fired? CO is a big issue. Do you have controls that if you have a leak, are you out there with a combustible gas indicator, an LEL indicator, and checking all your connections to make sure you don't have a leak of the fuel gas? If you have technicians going inside to adjust, and you need to do this, do they have a CO monitor on them? Do they have a temperature monitor? Do you limit the amount of time they're in there? Do they have a cool vest underneath their work clothing so that helps them do their job in those elevated temperatures? 140, 130 degrees or higher, the human body doesn't do real well at that temperature for that length of time. Do you have a rescue plan in place in case somebody goes down to get them out and cool them down? Do you have a fire watch, a fire monitoring plan? This is not an 8 to 5 technology. When you deploy heat, you're running it 24/7, 24 hours a day. You have to have a tech there, awake, cognizant, paying attention the whole damn time it's there, and you're deploying the heat. If it's a indirect fired, you've got diesel generators or something else with those inductive heaters. You have a lot of electrical current. Do you have GFI connections? Are they watertight? Is it going to rain when this thing is deployed, this equipment? Is it protected from those, if it's going to rain or the elements? Do you have it on wet ground? Security issues. You're going to have a lot of big duct work, a lot of openings in that building. You have to have security there. You have to have a fire watch. All these things come into play. All of them come into your plan. You have to have a plan. You have to have a pretty good diagram of where the air and the heat's coming in and how the exhaust's going out. Got to make sure where your exhaust is, it isn't pointing in the neighbor's bedroom window. Done that, not a good thing.
I've got another quick text question here, and then Cliff, do you have anything you want to?
Negative, Joe. I'm good.
All right, this is from I believe Darren Hudima. When heating materials, and it kind of follows in the things to watch out for. When heating materials that are saturated, need to understand that heat will have a great influence on where moisture goes, more so than vapor pressure. This is due to not heating all materials equally, thus driving the moisture deeper into the material or cavity, potentially causing condensation to occur inside of the cavity. I notice you're shaking your head in agreement on that, and I just thought it would be a good one to bring up.
Yeah, I don't know if I 100% agree with driving moisture deeper, because let's say go my 4x4, if I got a 4x4 in a water damaged building and I'm heating it from the outside and those water molecules are going out and it's more wet inside than on the surface of the 4x4, that water is going to want to come out, not necessarily drive deeper. So I've got a stew on that driving deeper. I don't see that happening. However, if you're in a water damaged multifamily building and you're just trying to heat one apartment or one dwelling unit and you aren't paying attention, you will drive water vapor into the neighboring units, either side or above and below, as you're trying to heat this space, because that water vapor is going to go somewhere if you're not pulling it out. And therein lies the science and the art of deploying heat when you're working on one space of a multi-space building. That is a very valid question in that circumstance. Yes. It's just, bed bugs. I mean, this is one of the biggest. Heat's great for bugs. I mean, bugs die at 127, 132 degrees pretty easy, most of your arthropods. And, heat is very effective at bed bugs. And in a multifamily building or a hotel or something like institutional building, you're trying to heat one space, those critters are going to crawl over to the space next door any way they can. And it's a big deal that needs to be paid attention to, yes.
Well, maybe we can get you two together after the show by email or something, but we really appreciate having you on. It's been excellent, Michael. And before we go, we always like to give you the last word. Anything we missed that you'd like to add? I wish we could have gotten into a little more on the third level, the bio kill, but you kind of just talked a little bit about that. Anything you'd like to add before we go?
You know, it's a great technology, like 50% common sense, 30% science, 20% is the art of the technology. We could talk about this all day long. This is great method it's got a lot of application, a lot of flexibility. And I really, 2 thumbs up to those people out there that are doing this and doing a good job, because I think it's really helping the public get remediation and mitigate using non-chemical methods. This works well when deployed correctly.
That's a good point. I'm glad you added it there at the end. Michael Geyer, thanks so much for joining us this week on IAQ Radio Plus. Very, very interesting conversation today. I want to thank my co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith at the controls. Most importantly, our growing group of loyal listeners and our sponsors. Thanks so much for the sponsors for making sure that we can continue to do this. And we'll be back next Friday at noon with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.